Handling millions of concurrent users is one of the biggest challenges in the system design, and it requires a combination of scalability, performance optimization, and smart architecture decisions. Let me break down this step by step. The first and most important concept is scalability. Instead of relying on a single powerful server, we scale horizontally by adding multiple servers. This means as the number of users grows, we can add more servers behind a load balancer to share the traffic. This approach is far more flexible than vertical scaling, where we try to put more power into a single machine. The second step is to use a load balancer. A load balancer sits between the users and the application servers. It distributes incoming requests evenly across multiple servers so that no single machine becomes a bottleneck. Most modern systems use cloud native load balancers like AWS Elastic Load Balancer or software based ones like Nginx or HAProxy. Next comes database scaling. When millions of users are hitting the system, the database often becomes the biggest bottleneck. To handle this, we use techniques like database replication, sharding, and partitioning. Replication helps with RAID scaling by creating multiple RAID replicas. Sharding helps by splitting data across multiple databases so that no single database has to store or process everything. Another very important part is caching. Not every request needs to go all the way to the database. For frequently accessed data, we store results in an in-memory cache like Redis or Memcached. This dramatically reduces response time and lowers database load. For example, things like user sessions, product catalogs, or trending feeds can be served directly from one cache. Then we need to think about asynchronous processing. Not all requests needs to be handled immediately. For tasks that take longer, like sending emails or processing payments, we use message queues like Kafka or RabbitMQ. This way, the main system remains responsive and heavy tasks are handled in the background. We also need to use content delivery networks or CDNs. When users are distributed across globe, serving static contents like images, videos, and style sheets directly from a central server can cause delays. A CDN stores these files at edge locations closest to the users, reducing latency and improving speed. Finally, we must not forget monitoring and autoscaling. Tools like AWS CloudWatch, Prometheus, or Datadog helps us monitor system performance in real time. With autoscaling in place, when traffic increases suddenly, new servers are automatically added to handle the load. And when traffic decreases, servers are scaled down to save costs. To summarize, handling millions of concurrent users is not about a single trick. It is a layered approach. Scale out with multiple servers, balance traffic with load balancers, optimize the database, use cachings for feed, process heavy tasks asynchronously, use CDNs for global reach, and finally monitor and autoscale for reliability. This combination ensures that our system can serve millions of users smoothly without downtime or bottlenecks.